Hi, I'm Bill Kinney, a professor of math at Bethel University in St. Paul, Minnesota, and this is video number 22 of my series on the foundations of arithmetic, algebra, and graphing, with a focus on real-life interpretation and application. It's actually the third sub-series in my overall large series here. The first sub-series focused on the arithmetic of integers. The second sub-series focused on the arithmetic of rational numbers. And now in this sub-series we're moving on to what I call decimals, real numbers, and percentages, with an emphasis on calculator usage. So I've got a calculator here, a graphing calculator that I'll use from time to time. Hopefully we'll try to get rid of the glare there. And see if I can find a non-graphing calculator as well to show you some ways of using that. That's part one of that. I'm good as far as applications go. Well, initially here I'm not going to really focus on applications so much as just real-life interpretations. And one big real-life interpretation will be in the area of dealing with money. A second real-life interpretation that will be helpful for us understanding this is measuring, and in particular measuring lengths. So I will use a ruler from time to time as well. I think to start off with this sub-series, it's important to start to understand the idea of place value. That's the fundamental thing that you need to start off by understanding if you want to understand decimals, real numbers, and ultimately percentages, and their applications. Just pretend, let's think of a money example here. Pretend you've got a certain amount of money in the bank. Let's pretend it's $3,764.17. So that's how much money you have in the bank. What I want to get across here is the true meaning of the symbols that we used, our decimal representation of the amount of money that you have in the bank. And what I'm going to say, if you think about it, is pretty obvious, but maybe you haven't really thought about it this way before. First of all, you hopefully remember that as far as these places go, that place, that spot in the digits there, that's called the thousands place. Thousands. The 7 right there, well, the second spot there, the third one to the left of the decimal, is called the hundreds spot, or hundreds place. The next one, which is 2 places to the left of the decimal, is called the tens place. And the one just to the left of the decimal is called the ones place, or ones spot. Hopefully you remember those. What might be a little harder to remember is the names given to the places to the right of the decimal. The one there that's in the place just to the right of the decimal is said to be in the tenths spot. Not tens, but tenths. And the reason, we will see pretty quickly, is that corresponds to the fraction, the rational number, 1/10. And the next number, the next digit there, is in the hundredths. I don't know if I'm spelling this right. Hundredth spot. I think that's right. Okay. Why do we give it those names? Well, because of what this number really means. Again, well, here's what it means. The fact that we have a 3 in the thousands spot means that we can think of this number being made up of 3 times 1,000 plus some other stuff. The 7 in the hundreds spot means one of the things we add is 7 times 100. I'm using a dot for multiplication here. That's going to be my standard thing to do from now on, mostly. Don't confuse it with the decimal. I'll try to put the decimal lower than where I put the multiplication. The 10 spot, there's a 6 there for the digit. that represents adding 6 times 10. And there's a 4 in the 1 spot, that represents adding 4 times 1. If you think about it, it's pretty obvious. This quantity here represents 3,764. You do have to be careful about order of operations. You would want to, in looking at this expression, you would want to do all the multiplications first and then add. So you'd have 3,000, a 700, a 60, and a 4. Then I'll add all those numbers and you'll get 3,764. But what about the 10th spot and the 100th spot? Those are related to fractions. The 1 in the 10th spot represents 1 times 1/10. 1 times the fraction 1/10. And the 7 in the 100th spot represents plus 7 times the fraction of 1 over 100. Okay, so that's what our symbolism, our place value representation of numbers means. It's called a decimal system. Deci is related to the number 10. 1,000, 100, 10, those are all multiples of 10, and if we had 10,000 and 100,000 and a million, those would be bigger multiples of 10. Actually, to be a little bit more precise, we call them powers of 10. This is 10 to the first power, this is 10 to the second power, this is 10 to the third power. 10,000 is 10 to the fourth power. The other numbers that you're multiplying the digits by, the 1 here, the 1/10 there, and the 100th there, are also powers of 10. 1 is considered to be 10 to the 0 power. I'm not going to write exponent notation, and maybe you remember it, hopefully you do, but I'm going to say that for a later video. 1/10 is considered to be 10 to the -1 power, and 1/100th is considered to be 10 to the -2 power. So we can have powers that are positive, 0, or negative, and that's what these numbers represent. I'll come back to exponents in a later video, like I said. To finish this video, this is just our start. This is the place value system, and it's already taken 7.5 minutes here. I just want to write down a couple rational numbers that you should very quickly be able to write the decimal representation of. Fundamentally, 1/10, 1/100th, 1/1000th, 1/10,000ths, etc. 1/10 represents getting a 1 in the 10th spot and a 0 in every other spot. Typically we'll write that as 0.1, though it's probably okay if you write it as 0.1 like that. Theoretically, you could even write it as, I don't recommend doing this, but you could even write it as 0, well, a bunch of zeros or even infinitely many zeros, then a dot representing the decimal point, then a 1, then infinitely many zeros after it. Okay, nobody ever does that, especially over there, but theoretically you could do that. Be content to do it this way though, one of those two ways. 1/100th means 0.01, or just 0.01 if you prefer. It is absolutely necessary to put that. It is absolutely necessary to put that 0 there. This is 1/100th. 1/1000th. It is absolutely necessary to put these two zeros there. And 1/10,000th. A couple valid ways to write it. Those 3 zeros are absolutely necessary. So there's our start with decimals. We'll continue with more decimal fraction relations and thinking about number lines in the next video or two.